So in this video, we are going to talk about the effects of substituents on acidity of carboxylic acids. By the substituents, what I mean is that if uh, we substitute one of the hydrogen atoms with a halogen atom. Basically, for example, chlorine. Chlorine is the most frequently asked halogen in the past papers. Basically, most of the uh, carboxylic acid questions in the past papers, they come with a chlorine as a substituent. So now let's compare the acidity of the two. Basically, whenever remember one general statement that the substituents, if the substituents are electronegative atoms, they are highly electronegative. For example, the chlorine atom, which is a halogen and is highly electronegative, if the electronegativity of this element or the atom which is attached is high, the strength of that acid always increases. So basically, this carboxylic acid, the chloroethanoic acid, is a stronger acid compared to the ethanoic acid alone. Okay, now let's talk about the reason why. And this question usually comes for again for like 3 marks, generally for 3 marks. It's asked for 3 marks in the past papers, in the paper 4 part, especially in the P4 of chemistry. This is a very popular question among the examiners, so let's prepare it very nicely. Okay, now this substituent over here, it must have an effect over the acid, over this acid in some way which might have increased the acidity of this acid. Okay, in the previous videos on carboxylic acid that we did, we made a comparison between the acid strength and the stability of the conjugate base. Stability of the conjugate base of the acid. Conjugate base of the acid. Okay, and in that video we also said that the greater the stability of the conjugate base, the greater would be the acidic strength. Okay, now let's talk about that. CH3COOH, ethanoic acid, when dissociates in aqueous solution, it produces CH3COO negative, the conjugate base, plus the H positive ion. Okay, this is our conjugate base of ethanoic acid. If this conjugate base has a high stability, the acid would be stronger. If this conjugate base has a lower stability, then the acid would become weaker. And the conjugate base of chloroethanoic acid, CH3COO negative, is gonna have a Cl instead of one of the three hydrogen atoms, and CH2 and COO negative plus H positive. Now in this case, the answers that the examiners, well, first let's look at the basic concept. This chlorine atom over here is highly electronegative, as we know, or it is electron withdrawing or electronegative withdrawing. So what it does is that it attracts the electron density from this negatively charged and towards itself. This attraction of the electron density, this electron withdrawing effect of this chlorine atom, it actually decreases the magnitude of this negative charge over the conjugate base. As the negative charge of this over this conjugate base decreases, this conjugate base is less likely to accept the positively charged hydrogen ion back. And if it is less likely to accept the hydrogen ion back, it is less likely to shift the equilibrium on the left hand side, and it is less likely to form this undissociated acid again. So if the acid remains in the dissociated form, that would mean that the acid is a stronger acid, because the strength of the acid depends upon the percentage dissociation. It depends upon the percentage dissociation of the acid. The greater the percentage dissociation of the acid, the stronger the acid. Okay, now whereas on the other hand, if we look at the ethanoate ion, we have an alkyl group in here, this methyl group. The methyl group over here, it will actually, due to the positive inductive effect, release its electron density towards this negatively charged end, and as a result the magnitude of the negative charge over the oxygen atom at the terminal, it will increase. And since the magnitude of this negative charge will increase, it will more likely accept this positively charged hydrogen ion. It is more likely to accept the hydrogen ion, because the opposite charges would attract each other more strongly, and this equilibrium in that case would shift on to the left hand side. And when the equilibrium shifts to the left hand side, the acid would exist in the undissociated form, and hence the percentage dissociation in case of in this case the percentage dissociation in case of ethanoic acid would decrease, and when the percentage dissociation decreases, the acidic strength also decreases. So as compared to the chloroethanoic acid, ethanoic acid alone is a weaker acid, because in ethanoic acid we have the positive inductive effect because due to the alkyl group, the methyl group, and in chloroethanoic acid we have the electron withdrawing effect of the due to the electronegative chlorine atom, which stabilizes the base. And in the case of ethanoate ion, the ethanoic acid, this base is destabilized. Okay, now this comparison is frequently asked for 3 marks. So now the answer that you guys are gonna include in your the points that you are gonna include in your answers. Okay, the first point is the first mark is usually for this saying which one is a stronger acid. So that's an easy mark that you guys can gain by saying that the chloroethanoic acid is a stronger acid compared to the ethanoic acid only. Okay, now the second mark that you guys will get is by explaining the stability of the two bases, the chloroethanoic ions ClCH2 CO negative. Now first let's talk about this. The chlorine atom, it contains an electron withdrawing or electronegative. The electron withdrawing chlorine atom, this is a keyword, electron withdrawing or electronegative. Any of the two words can be used. Electron withdrawing chlorine atom, it pulls the electron density from the negatively charged end of the conjugate base of this base of the chloroethanoate ion, and when once it pulls the electron density away towards itself from the negatively charged end of this ion, what happens next? It basically is it's the charge, the negative charge, it spreads over this entire molecule, and since the negative charge spreads, the base, the conjugate base, basically it gets stabilized. Okay, this is basically a very detailed answer that I've just written. Or if someone writes only this, that due to the electron withdrawing chlorine atom, the base is stabilized, or due to the pulling effect of due to the electron withdrawing effect, you can also write the electron withdrawing effect of electronegative chlorine atom stabilizes the base. This is enough for this mark. Stabilizes the base. Okay, so either of these two statements can be written. You may write the first statement or the second statement. You'll get 1 mark for writing any of the two statements. Then after this, the third mark that you can get is by explaining the destabilization of the ethanoate ion. CH3COO negative in the ethanoate ion, due to the positive inductive effect. Positive inductive effect is the keyword. So due to the positive inductive effect, the conjugate base of ethanoic acid is destabilized. Of ethanoic acid is destabilized. So these are the 3 marks that you can easily get for comparing the two. So the first mark is for stating which acid is stronger, and the remaining 2 marks are for the explanation. And then out of the, I would suggest that you guys should write all the 3 points to be on the safe side, but writing any of these two will earn you the marks. So it's up to you, but it's better to write all of these.